Hey guys, I hope you all have had a good week so far. As you know, this past week we've been talking about position, velocity, and acceleration. So we're going to explore that a little further with this investigating freefall lab. If you are at all possible can do this at home, I highly encourage it. This is a really awesome experiment. Of course, it's also great for you guys to get experiment with the lab than just watching me sit at home doing it as well. So if you can do this at home, please, it's fun. I enjoy doing it. But I know not everybody has all the materials to do this at home, which is why I'm making this video. So, investigating freefall. First off, what is freefall? Freefall is the movement of an object towards Earth because of gravity. So if I take this tennis ball, for example, and I just let it drop, gravity is pulling it towards the Earth. And gravity is pulling it towards the Earth at a constant acceleration of 9.8 meters per second squared, which means for every second, the speed is increasing 9.8 meters per second. So 9.8 meters per second, twice that, 3 times that, for every additional second, so on and so forth. Looking again at acceleration, hopefully you guys can recall that the acceleration is the rate at which speed changes. Now whether that is increasing or decreasing, it just kind of depends. So it's either going to start speeding up or start slowing down. In this particular investigation, we are going to look at, does horizontal motion affect the rate of free fall? That's what we are going to take a look at. And so that is the main problem of this, and I'm not going to read through every single thing. You guys have the materials, you guys can read through it. I'm just going to kind of lightly sum up everything. So, for the pre-lab discussion, you're supposed to read through the entirety of the lab so that you are able to answer these questions. First up is the controlling variables. You have to identify what each of these variables are in the lab. So the first one up is the manipulated variable. That's the independent variable. What is it that you are manipulating? What is it that you are changing in this lab? The responding variable, or the dependent variable. What depends or is responding to what you change in this experiment. And last but not least is the controlled variable. So what is being held constant, what is being controlled and held the same throughout the entirety of this lab. Number 2, formulating a hypothesis. So you need to create an if-then statement based off of how you think that horizontal movement will affect freefall. Okay, and then again, hypotheses are usually an if this, then that statement. Predicting for number 3. So you're going to make a prediction about what you think the result of this investigation is going to be. So do you think that one object is going to fall quicker if it's just in free fall versus if it's in motion, or vice versa? What do you think is going to be the outcome of this lab? Number 4, the controlling variable. Why are you told to let one object fall through a hole in the box instead of rolling the object off the edge of the table? I've read through this entire investigation. There is no mention of a box. So I'm not quite sure what it's asking there. So we're just going to ignore the whole box thing. And we're just going to say, why are you asked to have a trial where a ball is just free falling through the air versus just focusing on the rolling off the edge of a table? Okay. Number 5, calculating. How will you determine the average time for the 5 trials? So for each trial of horizontal movement in free fall, you have to time it 5 different times. So you're going to have to do 5 different trials. I need to be able to know what the average of those trials are. So you have to explain how you calculate that. And number 6, why do you think you will need a stopwatch that can measure tenths of a second? Thank you. My lab partner is my timer. And so he will be using my iPod. And so, for example, if I let it run for a second or so, I have 1.2 seconds. So that 0.2 right there, that is the tenth of a second place. So that's 1 2/10 of a second. Thank you. Okay, so materials. 2 small spherical objects. I will be using 2 identical tennis balls for this experiment. A stopwatch that I just showed you on my iPod. a meter stick and masking tape. I'm fudging those a little bit because I have neither. So I am going to be using this measuring tape, and 1 meter is approximately 30 inches. So I know it says a little bit later in the lab to put it out 1 meter. I am using 30 inches again because that's the approximate of where it's at. And then masking tape. Masking tape is to mark off the 1 meter distance. I don't have masking tape, and duct tape is going to tear up the carpet a little bit. So I have a ruler set on the ground, and that's where my 1 meter edge is. Safety, I know it says put on safety goggles. I'm pretty confident that a lot of you don't have safety goggles at home. Maybe some of you do. Awesome. I know I do from my college days, and we were required to have a pair of safety goggles, but I'm not going to use them because, quite frankly, you really don't need it. I mean, unless you're deliberately throwing these spherical objects at somebody in the face, which hopefully none of you are, caution, that would really be the only reason you need safety goggles. But not doing that here, so we'll be fine. So I'm not going to walk through the entirety of the procedure. You guys will see me doing it for the experiment. Read through it, of course, for all of the pre-lab questions. And it's there. You can read. I'm not going to read through everything. Moving on to the observations, that data table, I will be showing you the data. So when I do the first free fall and my partner records the time, he will announce the time and I will show it to you as well. And so we're going to do that for both the vertical and the horizontal motions. The result of part B is just strictly observations, no inferences, just facts. What happened? Oh, every single free fall was this time. Or, oh, none of their free falls were the same time. They all varied somehow. So just straight fact, what happened. And the analysis, so calculating. What was the average time required for the vertical free fall? What was the, number 2, what was the average time for the horizontal velocity? So when you move it horizontally, what was the average time for that? Part 3, did one sphere hit the floor before the other, or did they land at the same time? So in the procedure, as you will see, you start off doing one at a time, whether it's vertical and then horizontal, but then there comes part B, where you take one and one goes horizontal while the other is being dropped, supposedly, at the exact same time. I'm human. I'm gonna give it the best of my ability. I don't think you actually have to record the time for that. You just have to watch, does it happen at the same time, and write down what you think for number 3. And then last but not least, number 4, evaluating and revising. Does your data support or contradict your initial hypothesis? And I cannot stress the importance of this enough. It is okay for your hypothesis to be wrong. The only thing I'll be grading there is what you put. Does it make a logical if-then statement? So if you put something, if the ball is green, then it will fall down faster. I'm going to dock you points for that because that's not correlating the horizontal movement to the free fall. That's where you would get docked points. But if you say, oh, if the horizontal movement causes it to fall faster, that's a valid hypothesis because you're talking about the horizontal movement and you're talking about the free fall. So those are the 2 key things that I'm looking for with your hypothesis. But then you're going to then you are going to take a look back at all of the data points. Does it support or does it contradict what you initially thought? Again, it is okay to be wrong. Quite frankly, scientists get things wrong a lot of times, and so as we saw with the pinball video, things have to be revised and rephrased over and over again, and that's what this section is. And you can also make a conclusion based off of that. Last but not least is that go further section. Hopefully you guys saw it on the answer sheet already, but that is an extra credit section. I am not requiring that at all. You can do it if you want. I highly encourage you to. But basically, again, you guys can read, so I'm not going to go over it. But basically, it's like, okay, if you have 2 balls, what if one of them was a larger or smaller size? Or maybe it has a greater or smaller mass, weighs differently. How do you think that's going to affect the way that it falls? And so, similar to this experiment where we're looking at horizontal, you have to create your own experiment to test whether size and or mass would affect the rate that it falls. And so that's what the extra credit go further section is over. So on to the experiment. So I need to move out of the way. Alright. So it says for you to use a table, so I am using the edge of my desk here. And so for this first part, you are asked to hold a ball over the edge of the table, but not on the actual edge. The reason why you don't want it on the actual edge is because rolling it off is later. Right now, we just need it to fall straight down. So what I'm going to do is I'm going to take my pinky and I'm going to hold it on the edge. And so that tells me, all right, right here is the edge of the table. So when I drop the ball, that is it free falling, and I don't have to worry about any horizontal movement. My wonderful, lovely lab partner is going to record the time. And so for trial number 1, I will count down from 5, and I'll go 5, 4, 3, 2, 1, go. And so when I say go is when you hit start. Deal? Alright, and then of course hit stop when it hits the ground. So 5, 4, 3, 2, 1, go. Alrighty. 0.3 seconds. 0.3 seconds for trial number 1. Okay? Alrighty. Trial number 2 in 5, 4, 3, 2, 1, go.
Can you do that again?
I can do that again. This is science, and sometimes we need an extra trial. Things happen. Alright? So, trial number 2.2 in 5, 4, 3, 2, 1, go. My iPod's been dropped enough. It's fine. It's carpet. So 0.4 seconds. 0.4 seconds for trial number 2. Ugh. Alrighty. Trial number 3 in 5, 4, 3, 2, 1, go. 0.3 seconds again. 0.3 seconds for trial number 3. Alrighty, trial number 4. Trial number 4 in 5, 4, 3, 2, 1, go.
That's not right. I think I hit it right when you said 1. So.
Okay, try it again?
Yep.
That's perfectly fine. Alrighty, trial number 4 in 5, 4, 3, 2, 1, go.
1.1, that doesn't make sense.
Yeah, we'll try it one more time. He keeps
sorry.
getting 0.1, so we're testing it. We're just doing more trials for more accurate results. Alrighty, in 5, 4, 3, 2, 1, go. There we go, yeah. So that was trial number 4 and 0.4 seconds. So 0.4 seconds. Hint, hint, hint. This is why we need a timer to the 10th place. Final trial, hopefully, number 5. Alrighty, in 5, 4, 3, 2, 1, go. Ooh, fascinating. 0.2 seconds. 0.2 seconds for trial number 5. Alright. So, now comes the fun one. I'm going to practice this a couple of times first before we actually start recording the time, because for the next section under part A is I need to roll or push the ball with enough horizontal force to get it 1 meter away from the edge of the desk. Now, a couple of things. One is it's not masking tape, so if by chance the ball does manage to hit the ruler, it is subject to move, but the edge of the foam core board is also approximately 1 meter away from the desk. Second thing with that is my desk has a curved edge right here, so it's not 100% flat, which means there's probably going to be a little more variation with this. I'm going to try and push it off the middle of the curve as best as possible to keep everything consistent. But first things first is I got to figure out how to push it off with enough force to get it 1 meter away from the desk. So that was obviously not 1 meter. So let's try a little more force. Okay, a little further. Okay, just a little pass, but manageable. So if I go right here and go whoop, a little low. Ooh, that was too much force. Tinkle. Okay. There is hair attached. I shed. That's what happens when you have long hair. Alright, and push. Okay. I thought it was a little far. Try it just a couple more times just to be consistent. I think I just about got it though. Ooh, on the money! I would say I'm pretty consistent in getting that 1 meter mark. And my wonderful, lovely lab assistant agrees with me. So, you ready? Do you still want me to count down?
No.
No, okay. This one is also a lot harder, which is why I highly encourage lab partners, because now Esteban, my lab partner, he is going to have to eyeball it as best as possible from the moment it leaves the edge of the desk to the moment that it hits the floor, which means he has to have incredibly quick reflexes, which fortunately enough for us, he does. So, I'll probably do a 3, 2, 1 count, more for my sake, but just also to prep you. So when I say go is when I'm going to release the ball. It will not necessarily be when the ball falls off the edge. So
Gotcha.
We're not fancy like Mythbusters, and we don't have things specially timed and recorded, but we're doing the best we can. Alright, so 3, 2, 1.
That was a little off.
Try it again?
Yeah.
Okay, that's fine. 3, 2, 1, go.
There we go.
That was a little shy. Let's do that one more time because it was short.
Okay.
Alright, 3, 2, 1, go. Ooh.
Like that, because like it just went up.
Alright, so 3, 2, 1, go.
0.2.
Okay, so for trial number 1 under the fall with the horizontal motion was 0.2. So for trial number 1 under the horizontal motion is 0.2. Ready? 3, 2, 1, go.
0.2 again.
0.2 again for trial number 2 is 0.2. Ready? 3, 2, 1, go. That was short. We're doing that one again.
I was gonna say I can get it.
Sorry. Thank you. Yeah, you can. Alrighty, 3, 2, 1, go.
0.3.
That one. So trial number 3 was 0.3. That's funny. Alrighty, 3, 2, 1, go.
0.2.
Trial number 4 was 0.2. So trial number 3 was 0.3. Trial number 4 was 0.2. And hopefully last but not least, 3, 2, 1, go. Ooh, that was too far. That's why we're doing this. Alright, 3, 2, 1, go.
Do it again because I hit it right when you said go. I'm sorry.
Alright, 3, 2, 1, go.
0.2.
Alright, 0.2 again. And as you saw, I didn't quite hit it exactly on the ruler each time. that's okay. So long as you get it pretty close, we're fine.
And if the data is consistent.
Yeah, and the data is, again, pretty consistent. Alrighty, so now we are going on to part B, which is comparing the free fall. So, where is my second? There it is. Okay, so, this is going to be the fun one. Okay. Alright. So, do you want to do this with me, or like where you would just like stand right here and roll it off the edge, or drop it, or you want me to do it?
I don't know.
So like if I go to roll it off the edge, when it hits the edge, you drop. It's fine. I'll figure it out. Go ahead and toss it this way. Okay. I am not a professional. I do not do this on a daily basis to perfect it. So long story short, what I'm doing is I'm going to be rolling the ball off the table, and when it rolls off the table, I am also going to drop the ball. We are not timing this, but I am going to do it multiple times so that you guys will be able to see, does it hit the ground at the same time? That's what we're looking for right here. We're not timing it or anything, we're just looking, do they hit the ground at the exact same time? A little bit of human error because I'm having to eyeball everything, and I cannot promise a perfect release every single time it rolls right off the edge. So, let's see how this goes.
Yeah. I may be able to help. No.
Alright, so okay, so you guys can still see when this ball is rolling. So I'm going to hold this at the edge right here, and I'm going to roll this ball as best as possible. So that's child 2. Can you give me that one?
Yep.
It's a little on the other side. Thank you.
Mm-hmm.
So that was child number 2. So this is 3. Oops, that doesn't count. Interference. Alrighty. Nope.
Twist your hand. Yeah. Yeah.
No.
No.
Let me do my thing.
Well, like the way your hand is positioned to hit the other ball.
It's because I'm supposed to be rolling it that way.
Okay.
I had it for the first 2. Let me do my thing.
Okay.
Nice spin.
Thank you.
And I'll probably do it a couple more times because that one hit the backboard. I feel like I released early on that one. I knew that was going to hit the backboard, so I didn't hear a release on that one. Nope. Okay. I think that is enough to get the point across. Hopefully you guys enjoyed this video. If you have any questions, of course, I will be available on Zoom both Wednesday and Thursday as well. But again, I highly encourage you to try this at home. It's really cool. Hopefully you guys learned a lot from this experiment, and I cannot wait to see your lab reports. So y'all take care, and I hope you all enjoy the holiday weekend. Alright, bye guys.